One, two, three. One, two, three. Okay, so let's get started. Today I will try to speak about unlocking real-time applications using, for example, React. So at the beginning there is a challenge. Let's meet Rodrigo. Rodrigo is a software engineer and works on the front-end side of the complex e-commerce platform. And backend team, as always, just developed a new feature, and this is new API endpoint which allows to check status of the order, right? And today is Friday, of course, and there is an urgent business need to display this status on the front-end part of our complex e-commerce system. And Rodrigo is working until end of the day, and he deployed changes to the production. So everything went smoothly, and Rodrigo can go home or do different things. So basically we have always somewhere front end and the back end, but in this situation back end is more complicated. We have many microservices. And how Rodrigo solved this problem? Back end is not responding immediately. Status of the order comes after a few seconds or milliseconds, and correct status will be retrieved after some delay. So here is Rodrigo's solution. Rodrigo is using React, and the idea of the solution looks at the beginning, of course, like that. So we have endpoint, then we are fetching data and set status and display on the front-end part. But not everything went smoothly, so maybe Rodrigo should implement status change, because this status should be displayed again on the screen, and he tried to make another state cell. But after he realized that this status didn't come. So here is his brilliant idea to make interval and fetch data after each 5 seconds, 5 seconds, 5 seconds, 5 seconds. And as you probably can imagine, this probably won't work well on the production, but today is Friday, so what could go wrong, right? We will refactor this someday, but there is no day like someday. And backend, just remember, backend is not responding immediately, right? And there was a bug on the infrastructure. During the weekend, traffic increased, and people wasn't able to display status, their order status on the front end, because order status microservice went down. And how we can solve this problem? We have Monday, a few days later. Colleagues from the company opened Grafana, and their faces look like this. So we need to find solution for this problem. And customers who created new order during the weekend didn't get status, right? Moreover, there were thousands of requests that failed, and users just blocked our part of the backend because client was waiting for an event. My name is Patryk Omiotek, and today I will talk about how to implement servers and events on the front-end part. I'm a software engineer and IT trainer, so today we will talk about how to use right tools for specific problems and to create elegant solutions. But firstly, let's unlock real-time applications. What are real-time applications? Because we are creating front-end, so we have interactive applications, but are they real-time? Not at all. From the definition, real-time application is application that allows user to receive data from the server immediately. We have sending request each time, right? And it can be done by a variety of techniques like WebSockets, servers and events, or long pooling. Some use cases for real-time applications. For example, we can provide some chat and messaging, social media updates, news feeds, notifications for our, let's say, dashboards to notify users, for collaborative tools like online documents, etc. tickers or exchanges, tracking, for example, cryptocurrencies or real-time gaming. We can use real-time applications for these specific business problems. And the standard way, traditionally, we just have a front end or website, and this website is trying to fetch new data from the server, but we can also send events when it's possible to fetch new data, but we only should make it once, and the whole logic should stay on the backend, and the client is responsible for just receiving this data and make front-end logic and front-end magic. And moreover, these incoming events we can treat like just events with data and use this data inside the pages. So what are server-sent events? So maybe we will try to discuss what are not. Small comparison, because most of the developers one day need to choose probably between WebSockets and server-sent events. So just imagine that we have a huge stage, right? And it's our server, and our server sent message EO, for example, right? And here's client, here's client, here's client, and what client can do in WebSockets also send message, like EO, for example, and each client can send message, right? So we have WebSockets, and in this situation, we can have a mess. In SSA, we have similar situation, but clients cannot send message, and that's the whole comparison from the top. But from technical aspects, we have more differences like protocol, like communication, latency, and scalability is high in both situations. Of course, we can also use long pooling for our application where it's needed in particular situation. And here you have a technical slide. So maybe you can decide which technology use in your application. But okay, maybe a few lines of the code. We'll start from the server part. The easiest way, just to use Node.js and send few crucial headers. The first one is text event stream. So we know that our server is sending events to the clients with no cache, because we need to have fresh event each time, and we want to keep this connection alive. So the rest of the code looks like this. And below, there's a client write. So we are sending message with data structure. Data can be a string or an object. So let's assume that we want to send prices of cryptocurrencies or of the stocks. So we are just sending a string. The good practice is to keep message event interface in our backend structure, and we have data and ID. ID is crucial if you want to reconnect our streams to different clients in situation that a connection failed, for example. And for those of you who prefer, for example, to use Next.js, there's easiest way, because there is a decorator in Next.js, so only we need to use this decorator for our endpoint and create method, for example, send event, and its observable stream which implements, uses this message event. So for example, we have an interval which takes each second and sending data hello. More of the code, so we have controller with sending this message each second. We can do it different way, of course. If you prefer more RxJS syntax, we can create event from event, like here, and use event emitter. Event emitter is really useful in the backend architecture, because if you want to communicate many let's say, instances of our backend, or just inside one instance of our backend, we want to communicate each other, we can also use an emitter for these situations, and emit events between backend application, or like this. How to debug, or how to check if our endpoint is working correctly? Simply in the Postman. When you want to make a request to specific endpoints, so for example, order status, Postman automatically detects that we have a stream, and here's the result of making request to this endpoint. So we have this tick each second, and it's the zoom of this solution. So maybe frontend, there is a time for the frontend implementation. And of course, we can use React, we can use Angular, we can use Vue, Vanilla.js. What do you prefer? But the most crucial thing is to use native event source object. And event source is just event source opens persistent connection to HTTP server, and this server sends text event stream format. It's crucial that we have HTTP server. Server send events, and event source is accessible in most major browsers, so it's easy to use. We don't need to install any additional dependencies. And the first try, for example, to use event source is to just create new instance of event source, and we have on event source we can attach listeners, only use message connection error handlers to handle new message errors, or just close logic to our application. But in this code, there is the same situation that many developers forgot, because always validate your incoming data, even from the backend, and your application will be more stable. So Rodrigo decided to use React and event source to refactor his code to check status, and just Vue implementation is to display messages. On the front-end side, we can use, for example, developer tools in Chrome. In section network, there is event stream tab, and we have same situation when our front-end is implementing correctly servers and events. Okay, we have many advantages of using this form of the communication. So in your application, of course, you need to discuss and choose if it's wrong, if it's a good way to solve business problems. So when to use? For example, it's simple to implement and understand, because we have this native object, and we need just to attach our listeners on the front-end side, and fetching events goes under the hood automatically. It's built on top of HTTP, so we don't need to use additional libraries or any different solutions. Error handling is quite interesting because from one side it works automatically, especially on the backend side, and backend is trying to communicate with frontend and retry the connection. Of course, we have these listeners on the errors, and we can display message or retry manually, but it works automatically, and is supported by most major browsers. But of course, and scalable, of course. But of course, there are some limitations where maybe SSE is not the best for your project. So the first point is it's one-way communication, which from the other side can be, of course, advantage. So it depends of your application. It's not supported by some Internet Explorer, so if you are developing application to government, maybe it's not the best idea to use servers and events. And on HTTP 1, there is maximum limit of 6 connection at the same time, but in HTTP we can have much more. And its overhead compared to WebSocket in some scenarios, and doesn't support binary data. So if you want to send binary data, definitely you should choose WebSocket instead. Okay, about this error handling and connection management. Server, basically server tries to process the request, send event to the client, and after sending the event, there is a message with status 200 OK, and content with our message with data. So messages are going through server to the backend, and having timeout, client tries to reconnect to the backend. Of course, there may be a solution that backend failed. So on the front-end side, we of course should implement logic for reconnecting or disconnect. Never forgot about this situation. So by default, it handles connection, loses, and tries to re-establish connection, and listening to these events in React or any other front-end library or application is really easy to maintain and develop. There is some techniques to optimize and best practices. So for example, our server is sending huge amount of events each time. So we can, for example, use throttling, so make a package of our event or delay sending the events, or using bucket strategy to make a probe, and this probe will detect if our connection is stable or just we want to make some operations to optimize sending these events to the client, and we want to close connection when it's not needed, because we have this automatic reconnection. But sometimes in our applications, in our front-end application, there is no need, for example, to keep this connection alive. For example, we want to fetch this order status once, so we don't need to have open connection each time. One other use case, let's assume that Rodrigo is building new project, new platform, like AI, image processing platform, or real-time notifications, or line use, collaborative tools, etc. One of these examples. And he decided to build AI processing platform, and he uploads to the server an image, and there are some operations on this image, like resize, remove background, grayscale, and each operation works in different pipe on different microservice. And when this operation will complete, we don't know, right? So at the end, we can create this endpoint notifying client that which logs each operation and notifies client that the whole process, of course it can be much more complicated process, has ended. Okay, some tips. React is good example to use SSA, but as I mentioned before, you can use it in just native JavaScript. There are cores, so if you're starting, let's make sure that your backend has cores configured correctly to allow our frontend to use events. Of course, you can set headers, but in some situations, there is polyfill, for example, if you want to use token for the communications. And always remember to design in terms of creating architecture, implement, refactor, and repeat, because there is no easy solution for implementing that for each scenario. You need to make experiments for that. And on the front-end side, State Manager can be useful in some cases because we can have many connections, not only one connection to our to our server. We can have plenty, or for example, for each operation of processing these images. So of course we can use, for example, Redux or Mobex to have information that from the backend we have an event and let know frontend that we need to process somehow this event on the UI. And we have conclusion. So of course it's not the ideal solution. It won't solve your all problems, but definitely I recommend you to try use SSE in your infrastructure, in your projects, because it can allow you to make things faster and more stable and more secure. And that's all from me today. Thank you for your attention, and see you later.
Hey, thanks for that. I'm a fan of server-sent event myself, but I didn't have a chance to use them yet. Let's have a seat and talk about reasons to use them, because that's likely our first question. So, okay, we have some very detailed question, but yeah, let's start with a highlight. Like, give us one reason to use server-sent events instead of a WebSocket connection. Let's make it very short and memorable.
Okay, WebSockets have this bidirectional communication. So, for example, for chat or for messages, WebSockets are better because we have two streams of sending data. But in many places, in many applications, it's just overwhelming, and we want just to listen this request from the server. And remember, what stays on the front-end side in the client can be modified by, for example, attackers. So why we want to open these doors for someone?
Yeah, and there's a reverse of that question. So it says you can have specific WebSockets channels configured to be only publishers or only subscribers. Does it mean that you could configure your WebSocket stuff in a way that could be used as an SSE?
We can. WebSockets are using PubSub mechanisms, so we can just use sub subscriptions. So yeah, using one channel.
And would it be consumed by the browser as an SSE source, or would you have to write something yourself?
It still will be WebSockets, because SSE and WebSockets are working on different protocols. WebSockets has TCP, so we have WS at the beginning of the protocol. So two different protocols, two different solutions, which works similar, right?
Yeah. Okay, and I have this big thing here. I'm going to read it out for you, and let's figure it out. So, how are the clients registered on the backend? Is there some kind of handshake with the client, or is it implemented by the event source object in JavaScript?
At the screen with the Postman, there was one line with the URL of the connection, and second one looks empty. It was something like preflight, and this preflight checks, like with the standard HTTP communication options, if we have an access to this connection. It's the 1 point from the front-end side, and the front-end from the back-end side. There is, in this message event interface, we have data, property, and ID. Setting ID for each customer makes it's unique for each client. So server, for example, knows that this client is using this stream, or there is a need for maker connection for a particular client.
All right. Now for something completely different. How would SSE solve Rodrigo's problem if the backend status microservice is down?
So we have information, is this connection stable? And the easiest way just to listen in the listener on error that something is wrong. There are some techniques like create on the front-end side timer or counter, and this timer ticks, for example, after fail 2 seconds or 3 seconds, and check if there is a possibility of make new connection. If not, we can close this connection and display just error. Sorry, user. Let's back later or after a few hours.
Okay. What is the best way to close a connection when we received all the data we wanted from the server and we no longer want to listen to it?
Okay. On event source, we have a close method, and we can just use it.
Okay.
That's simple.
Simple as that. All right. So the current top question is a tongue twister. Did you use nest with C in next with X APIs? Nest in the next.
Yes, but I'm also conducting workshops. During the workshops, yes, for demonstrating some things. On production applications, it depends. Sometimes Next is using Nest together. Sometimes our frontend is using backend directly, but because mostly we are creating internal applications, so we can we don't need Next in project that I'm working on.
Okay. Thank you. That's it for the questions, but I bet you can find him and ask him more.
Thanks.